Hi everyone, today I'm going to talk about a secure scalable system I designed for high performance data exchange across mobile, web, and backend platforms. This architecture was designed to address several pressing needs, enable dynamic and fine-grained data access for client applications, support secure and efficient communication between backend services, enforce enterprise security standards such as mTLS, RBAC, and OR2, and ensure observability and resilience across services running on Kubernetes. First, we have the clients layer where we can see the entry points and access patterns. And this tier includes mobile applications primarily used by the end users and web portals serving both customers and internal users who need slightly more detailed dashboards. And we have internal backend systems which include ETL pipelines, schedulers, and legacy services that interact with our core APIs for batch processing or data sync. Each of these clients interact with a platform via secure HTTP or gRPC calls depending on the context. Mobile and web clients use GraphQL over HTTPS to send queries tailored to their UI needs. Then we have internal backend systems typically communicate via gRPC, which provides low latency, high throughput binary communication. Next, we have API gateway and identity layer. This manages request management and authentication. All incoming requests first land at the API gateway layer. This gateway supports both GraphQL and gRPC. GraphQL enables clients to request exactly the fields they need, nothing more, nothing less. This minimizes payload size and improves performance for mobile users. gRPC supports binary protocol based remote procedure calls, ideal for internal services exchanging high volume structured data. Request to the API gateway must include an access token, typically a JWT issued via OAuth2 compliant authentication flows. These tokens contain subject or user ID, scope, role, or permissions, and an expiration timestamp. The gateway validates this token through the authentication and identity provider, which in our case is Keycloak. Keycloak handles user login via standard OAuth2 flows, authorization code, client credentials, etc., and token issuance and introspection, and role-based access control RBAC policies based on user or client roles, integration with internal identity providers like LDAP or custom user DBs. Once the token is validated, the API gateway routes the request to the appropriate microservice. with the authenticated user context attached. Next, we have backend services and infrastructure layer. Here, this layer handles business logic execution. The backend is composed of microservices running in a Kubernetes cluster. Each service is containerized and designed to be independently deployable. Key services include user profile service, master data service, transaction sync service, audit and log service. User profile service accepts GraphQL queries from web and mobile clients to retrieve or update user-specific data like name, email, preferences, and notification settings. Performs token-based access checks to ensure users can only access their own profile data. Uses GraphQL's type-safe schema to enforce contract-first development. Master data service exposes both GraphQL and gRPC interfaces. GraphQL is used for front-end applications to request reference data like country codes, product types, and fee tables. gRPC is used by internal backend systems that need to fetch or synchronize large master data sets in batch, example for nightly updates or cache refreshes. Master data service updates are version controlled and support zero downtime rollout strategies via blue-green or canary deployments. Transaction sync service exclusively uses gRPC for performance and binary efficiency, handles high-frequency data sync operations between internal systems such as pushing transaction data to caching layers or reconciling balances. Operates in real time and support streaming RPCs for batch data ingestion and even propagation. Audit and log service receives log and event records from other services using asynchronous gRPC calls, automatically records who performed an action, what was changed, and when and where it occurred. These logs are later used for security, audits, and compliance reporting. All these services communicate within a secure environment and enforce token validation either directly or via shared libraries and policies. The infrastructure layer contains Kubernetes, Istio, and observability. Each microservice is deployed as a pod inside a Kubernetes cluster, and every pod is paired with an Istio sidecar proxy envoy. These sidecars act as transparent intermediaries for all network traffic in and out of the microservice. Here's what they handle. Security, mTLS. All service-to-service communication is encrypted via mutual TLS, mTLS. This ensures both the client and the server in any internal transaction are authenticated and that data is encrypted in transit. Traffic routing and policy enforcement. The Istio control plane configures routing policies dynamically. This includes load balancing, retries, circuit breaking, rate limits, and even A/B testing scenarios. It enforces authorization policies using rules that evaluate JWT claims, roles, or namespaces. Envoy sidecars generate detailed telemetry data automatically. Request and response logs, latency measurements, error rates and retries, TLS handshake status. These are some of the telemetry data. These metrics are aggregated and exported to Prometheus and visualized in Grafana dashboards. Developers and SIEs use these dashboards to monitor health, identity bottlenecks, and debug issues in production. Centralized security and threat modeling. All Istio configurations such as security rules, routing policies, and rate limits are defined centrally and pushed to the proxies at runtime. These configurations feed into a security and telemetry subsystem responsible for mTLS certificate lifecycle management, routing, dynamic routing control, logging, tracing, and metric collection, enforcing fine-grained authorization. Above this, we maintain a threat modeling and compliance layer which leverages the telemetry data to conduct regular penetration testing, review RBAC configurations and violations, run audits based on activity logs, prove compliance with standards like SOC 2, ISO 27001, or internal policies. This architecture delivers many system impact and benefits. This architecture delivers tangible improvements. We have observed reduced client response times by over 40% through more efficient GraphQL queries, and enable seamless scaling of services with zero downtime via Kubernetes and Istio. Improve developer onboarding with self-documented schemas and standardized API patterns. Passed multiple rounds of internal and external security audits, making it the backbone of secure data exchange within the organization. This is a cloud-native system built to balance security, performance, and flexibility. Thanks for watching and see you in the next one.